Hey guys, so this video is going to focus on how to solve equations, or more specifically, how to solve rational expression equations here. So if you're dealing with equations where you have rational expressions in them, so remember, rational expressions are just fractions where you have polynomials in the numerator and in the denominator. So here I have this example right over here, and we need to solve this thing. So we actually need to solve this for x, right, and get an answer x equals so-and-so. Now, when I look at this problem here, and it's specifically the way that this problem here is set up, I'm actually going to solve this a little bit differently than maybe how I would normally solve equations that have rational expressions in them. Because when I look at this problem, this is actually what I see when I look at this problem. I see a proportion. Right? I see that I have one fraction set equal to another fraction, and in order to solve a proportion, we could actually cross multiply. Do A times D is equal to B times C. So I'm actually going to use this concept right here to solve this equation over here. So I'm going to use cross multiplication in order to do this. So if I'm going to use cross multiplication here, that means I'm going to take 4x minus 1 and I'm going to multiply it to 6x minus 2. And then that's going to equal 2x plus 3 times 12x minus 25. All right, so I'm going to use cross multiplication to write the problem this way, and then after I actually use the cross multiplication rule here, that we do have a lot of simplifying that we're going to have to do. So our next step for this problem here, after we cross multiply as well, we need to go ahead and multiply these binomials out and get them a little bit more simplified so we can work on solving this thing. So on the left-hand side, so I'm going to go ahead and use the FOIL method. Right, FOIL method, first, outside, inside, last, just tells us an order in which to multiply two binomials together. Starting with F, which stands for first, 4x times 6x gives me 24x squared. O stands for outside, so these outside two here, 4x times negative 2 gives me a negative 8x. Moving on to the inside, so I is inside, negative 1 times 6x is a negative 6x. And then L stands for last, negative 2 times, negative 1 times negative 2 is a positive 2. Now let's go ahead and FOIL the right-hand side as well. So first, outside, inside, last, starting with first, 2x times 12x gives me 24x squared. Outside, 2x minus 25, that's a negative 50x. Inside, 3 times 12x is 36x. And then last, 3 times negative 25 is a negative 75. All right, so we're left with all of these terms here. So the next thing that we're going to have to do here is we're going to have to work on simplifying this thing. So because I do see that we have quadratics here, I am going to work on moving everything over to one side of the equal side so we can have this set equal to 0. So let's maybe combine some like terms though before we do that. So I'm going to drop down the 24x squared. Negative 8x minus 6x, that gives me a negative 14x. And I'm going to drop everything else down until I get to these like terms over here. Negative 50 plus 36x. That gives me a negative 14x. All right, so what I'm going to do next is I'm going to take this right side and I'm going to move it over to the left side over here. So I'm going to say minus 24x squared and minus 24x squared. Remember, what you do to one side, you have to do to the other side. And at the same time here, I'm going to go ahead and add 14x to both sides. But when I do that, so I know this is something a little bit funny is going on with this problem here. Because on the right-hand side, if I'm moving that 24 over, well, 24 minus 24x squared cancels. And negative 14 plus 14 cancels. Okay, I'm going to drop down the negative 75 for right now. On the left-hand side, though, we had 24x squared, and we subtracted 24x squared. So that's going to cancel. Same thing with my x terms here. Negative 14 plus 14 cancels, and leaving me with just this 2 over here. I'm left with the 2 is equal to negative 75. Now, I don't know about you, but 2 does not equal negative 75, right? This is actually one of our special cases when it comes to solving equations with rational expressions. So this is actually a no solution. 2 doesn't equal negative 75. I would definitely maybe go back up just to make sure that I didn't make a mistake somewhere. Maybe I accidentally calculated wrong. That's possible. I do make mistakes all the time. But I'm pretty sure that I did this correct. If not, you can definitely comment down below and let me know if I did make a mistake here. Otherwise, 2 does not equal negative 75. I'm getting an answer that just does not make sense. So that does not necessarily mean that you did something wrong. Every once in a while, we are left with an equation that is one of our special cases. Now, the special cases are typically infinitely many solutions or no solution. If you're left with one like this where the answer just doesn't make sense, these do not equal each other, there's no possible way of those equaling each other, this is a no solution. So otherwise, no solution, and we are done with this problem. There's nothing else left to do here.